Okay, so I'm Orit Khan, Assistant Professor of the Gargi Memorial Institute of Technology, Basic Science Department. So, in this chapter, in this lecture, we have to study about the some basic statistical mechanics, some basic term of the statistical mechanics. In the last lecture, we study about the what is microstate and what is macrostate. So, in this lecture, we try to develop the condition for maximum and minimum probability of state let for the n particle in two boxes. In the last lecture, we already separated the n particle in a two boxes such type of way. Let number of we just distribute in a such type of table way. Okay, macro state probability, number of microstate probability. Clear? So the distribution n0, n minus 1 1, n minus 2 2, and such a way n minus r 0 n was the probability for every state. 1 by n plus 1, 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 because in a macro state every state is equally probable. In the case of the micro state we chosen for this one the most probable state. Most probable state is n factorial by n minus r whole factorial by n factorial. So what is the probability for the first state? Must be 1 by 2 to the power n, and the last state must be 1 by 2 to the power n. In the case of the most probable state, the probability is 1 by n factorial n minus r whole factorial into 1 by 2 to the power n. Okay, it is the probability distribution for the most probable state. Let's choose. So now we have a most probable state for the microstate. Okay, microstate. We have an equation for the. This is represented the probability distribution of the most probable state. Let choose r equal to n by 2. Why r equal to n by 2? We just find out the distribution for the two boxes have an equal number of particles. So obviously if r is n by 2, so n is this box is also have an n by 2. The distribution for the r by n by 2 is n by 2. Just we try to find out the probability for the in that case. Okay, for example, let n equal to 10 for the 10 particles. So number of particle equal to 10. So obviously r is equal to n by 2, that means 5. Then the probability for the 10 particle, probability we write by P1 is obviously n factorial by n minus r whole factorial n factorial into 2 to the power n. So 10 factorial by 5 factorial 5 factorial into 1 by 2 to the power 10. Is it clear? We just find out this case is the most probable or not. This is most probable or not. That's why we get some example for the n is equal to 10. Okay, this is the most probable state for the 10 particle distributed in a 2 boxes. Clear? So if you broken down this equation, 10 factorial means 10 into 9 into 8 into 6 into 5 factorial divided by 5 factorial into 5 into 4 into 3 into 2 into 1 by 2 to the power 10. Just cancel out the 5 factorial, 5 is divided by 2, 2, 2, 4 2 is 8, 3 2 is 6. We get 252 into 10, 2 to the power 10. Clear? This is the when n equal to here r is the case for the r is equal to n by 2. That means r is equal to 5 for the n equal to 10. Now this is the probability of the most probable state. Now we can slightly change the value of n by 2 to check it is max or not. Clear? For r is equal to 6, n is equal to 10. So obviously n minus r equal to 4 become, okay, just we chosen a 2 box for the 10 particle distribution. There have a 6 particle in here and the 4 particle in here. So in that case this one is a 5 5 equally distributed. Clear? So in that case we just slightly change the system. Okay, so P2 is become 10 factorial n factorial by r factorial n minus r factorial 4 factorial into 1 by 2 to the power 10. Clear? 10 into 9 into 8 into 7 into 6 factorial divided by 6 factorial into 4 into 3 into 2. It is coming 210 divided by 2 to the power 10. We can see that P1 is always greater than P2. In the case of the distribution when R is 6, we just see the R, this box contain the 6 particle, this box contain the 4 particle, this total distribution function is there. Similarly, if R is becomes 4, if you change the distribution slightly, change the distribution in the opposite direction. If R is become 4, the box is become like 6 and 4. That obviously in this case the distribution function is also 210 by 10 to the power 2 to the power 10. So in to verification we can conclude that in the R is equal to n by 2 is the maximum probable state. Clear? This is the maximum probable state. So now we try to find the maximum probability equation. The maximum probability for n is equal to r is equal to n by 2, n minus r is equal to n by 2. So obviously P max is equal to n factorial by n by 2 factorial n by 2 factorial into 1 by 2 to the power n. So can rewrite n factorial by n by 2 whole factorial square 1 by 2 to the power n. This is the P max. The minimum probability. Everything is we are calculated for the micro state, okay, micro state, not for the macro state. The minimum probability when r is equal to 0 or r is equal to n. How? The extreme one and the extreme less, okay. So P minimum is n factorial divided by 0 factorial by n factorial into 1 by 2 to the power n. This one is cancelled out. We know that 0 factorial is equal to 1. The minimum probability is 2 to the power n. How can you distinguish that this one is a minimum? Let we take an example. Let 10 is equal to 10, r is equal to 1. So P2, let 10 factorial divided by 9 factorial into 1 factorial into 1 by 2 to the power n. So this is become 10 into 9 factorial by 9 factorial into 2 to the power n. We want 10 by 2 to the power n. So from this one P2 is become this one. So we can rewrite that P2 is always greater than P minimum. For the slightly change of the value of the r is become 1. R is become 1. The value is become 10 by 10 to 2 to the power n. So that means the P2 value is always greater than this one. So we can rewrite that. We can say that this is the minimum probability state. This is the verification for by through an example. Is it clear for everyone? Okay. Now we study about the another new term is known as thermodynamic probability. Okay. So what is thermodynamic probability? Let we try to distribute the 3 particle in 2 box. For the macro state, obviously we have a 2 1 1 2. This is the most probable state. It is distributed by 3 1. So for the microstate, obviously particle by written by ABC. Okay, because this is a distinguishable particle, obviously. BCA, BAC, CAB. Similar things happen is here. Oppositely. So for this macro state, we have a 3 microstate. For each macro state, for this macro state, I have a 3 microstate. So this 3 is called the frequency of the system. Is written by 3, or the thermodynamic probability equal to 3. That means for each macro state how many number of microstate you have, such number is known as the thermodynamic probability. Is it clear? So let's see the for n number of distribution. So in that case, suppose for the 2-1 case I have a 3 frequency. For the 2-1 case I have a 3 frequency. Clear? The frequency is 3. The frequency is also 3 in here. In here, okay. So for the each macrostate, how many number of microstate is known as a frequency or the thermodynamic probability of the system. In by the definition, the number of possible microstate corresponding to any given macrostate is known as thermodynamic probability. Is it clear for everyone? This is the today's topic. You can find out the maximum probability state for the microstate, maximum probability state for the microstate, minimum probability state for the microstate, because in a macrostate every probable state is equal. So that's why in a macrostate it does not need the maximum or the minimum state. Because in a macrostate every state is equally distributed. Every state has the equal probability. But in the case of the microstate, we can see there is a certain value is changing from the first distribution to the last distribution. That's why we need the maximum probability state and the minimum probability state. So in this lecture, we find out the maximum probability state. This is for the n is equal to r is equal to n by 2. When the total number of particles is distributed by this total number of bucks by a same number of particle or distributed in a equilibrium, the total number of particle is distributed by the total number of box by a similarly same number of particle distributed in the similar sorry, actually I am saying that the total number of particle is distributed by the two box by a equally. So such type of case is known as most probable state, and such type of case when some box is vacant and the rest of the box is fulfilled by the all particles, such type of state is known as minimum probability state. So in this lecture we just developed the equation for the maximum probability state and the minimum probability state for the microstate system. Then we just find out the thermodynamic probability definition. What is the number of possible microstate that for a specific corresponding macrostate is known as the thermodynamic probability or the frequency of that state. Is it clear? So next day, in the next class, we study over another new term we studied. That one is called phase space. Okay, thank you.